Hey everyone, we're going to look at stationary points for our curve y equals 16 minus x to the fourth. We're going to find each stationary point and determine what type it is. And then we're also going to find our x and y intercepts. That's this part. And you can also check with your calculator. So we're going to use these steps here and for the graph. And the first thing we're going to do, the stationary points can be either a maximum, a minimum, or an inflection point. So let's look and see what we have. So the first step is to take the derivative of our curve, and we're going to get negative 4x cubed. Now set that to 0 because we're trying to find the gradient, the tangent line, and we get x is 0. Now when x is 0, you plug that 0 in here to see what your y value would be. That would be 16. So this is what we're looking at. We're just looking at one point. Is it a maximum, a minimum, or an inflection point? So what we do is take the derivative, second derivative, or the derivative of this equation, and we're going to get negative 12x squared equals 0, and so we still get 0. So that suggests that since the derivatives are both 0 for the gradient, that means it could be an inflection point. So our thing is, if we have a positive, it suggests a minimum, negative a maximum, and 0 could be either a minimum, a maximum, or an inflection point. So what you do is you take your 0 here, and we only have 1 point. So we're going to have to see what happens when x is less than 0. And we look at it in our first derivative, because that's what we're looking at. We're looking at the tangent lines of the curve. So say the curve looked like this. We want to know what happens, and if we're at 0 here, we want to know if this opens up or down, if you will. So if I plug in negative 1, so negative 4 times negative 1 cubed, that's going to end up being positive. So this is going to end up being positive when x is less than 0. That suggests, it's positive suggests minimum, but let's just put positive here. All right. Now, what happens when x is greater than 0? So if I put in 1, say, get negative 4 times 1 cubed, well, that's going to go to negative. And we only have 1 point. So since these are different, that means we don't have an inflection point. An inflection point, they would be the same. You'd have something like this for an inflection point. Or you could go the other way. So if these were both positive, then this would be an inflection point right in here. If these were both negative, then the curve would look more like that. But we don't have that. We have a positive and a negative. So just remember that. That just is going to mean that we're going to have a graph that looks something like this. A positive gradient when x is less than 0, and a negative gradient here. So that means we're going to have a maximum. Now let's find our, we already know the y-intercept is 0, 16. That's actually our maximum point as well. And let's find our x-intercepts. So let y be 0. I'm going to factor this as 4 minus x squared times 4 plus x squared, our difference of squares. This you can't factor, so we're just going to look at that. We're talking about the real numbers, so this is 2 minus x times 2 plus x. that means our x-intercepts are 2, 0, and negative 2, 0. And then this is our max. So I kind of graphed it here. And there's your tangent line where it's 0 when we took the derivative. And what this is saying is when we check, this is at 0. So we checked values less than 0 and plugged it in our first derivative. And we found that that tangent line is positive. When we checked values greater than 0 this way, we found that our, if you do a tangent line here, the gradient is negative. That's why this point here, which is also our y-intercept, is going to be maximum. Because it went from positive to negative. And that's it. Thank you. Have a nice day. Bye-bye.